What I'm going to talk about is the fun project that I built a few months ago that is based on my podcast data and how I use ApertureDB and what I did with it. It's you basically, I can chat with my data and ask questions and don't have to go through all the podcast data.
Just to fill in, I'll be talking about a new workflow we're coming out with shortly, which is going to deliver a full pipeline from crawling a website all the way through to having a RAG agent. And I'll be talking about the steps on the path and giving you a quick demonstration of that. Well, ApertureData, small software company, we produce the ApertureDB software, which is a hybrid of an image video store, a graph database, and a vector store. So those three can all be harnessed together through the one query language. So it's a one-stop shop. It's this integration of features. It saves a lot of the headache that you would normally have if you're trying to do various different tasks in the machine learning world. And it allows you to have one solution that covers a number of different bases for you. We're going to be talking about workflows in a minute, but this is we recently rolled out our cloud portal, which is exciting because it allows you to set up new ApertureDB instances in a self-service way that's much easier and simpler than anything we've had before. And we're adding workflow infrastructure around that, whereby a lot of common tasks can be automated with a few clicks of the button. And I'll be showing some examples of that in my presentation.
Everyone, and as I mentioned earlier, I'm going to talk about the project that I worked on. So I'm Sonam Gupta. I currently work as a senior developer advocate at aiXplain. And the topic of my talk today is from podcasting to instant insights. Now, I host a podcast and I have many episodes so far. Now, going back to all the videos and audios to go listen to it just to get some insights, that sounds monotonous and time consuming process. So now what I thought of doing that to resolve that is to turn all these hours of podcast audio into instant searchable insights. So you can, ask questions, figure out what was the topic that was talked about, and many other questions. Now, how I did it is pretty simple. I took all the audio files from the podcast, which was, of course, pre-recorded, that were already recorded. I transcribed them using OpenAI's Whisper model, which was pretty accurate using that model. And then I took those Whisper text files, or sorry, transcribed text files, and stored it in ApertureDB. Now, it helped me organize all the transcripts and metadata for efficient retrieval. And what I could do, basically, you making the text machine understandable, I could use that transcribed text on ApertureDB for semantic understanding, and just not just semantic understanding, but also chatting with it. To talk just a little bit about the technical details, I used Cohere's embeddings to transform the text into numerical vector representation without going too much into what embeddings are. And of course, I use LangChain's integration with ApertureDB for doing a lot more, whether it was chunking and just making it a streamlined workflow for me to build this particular project. Now, I don't want to go into too much theoretical detail. Instead, I would like to show you a quick demo. But before the demo, I would want to show like how I could do the semantic search and chat using ApertureDB. Now, the edge or the power of ApertureDB lies here. First, you can, of course, do a quick smart search for contextually aware results from all the podcast transcripts that I stored. Then I have this interactive chat where I used Cohere's Command R plus model, where I can just simply ask question and answer directly from to with my podcast data. And using ApertureDB, I can scale for as many transcripts as I want, as much data as I want to add, because it can handle the growing collection with providing consistent performance throughout the data. Throughout the process. And of course, given that it's unified platform, it integrate all the metadata and the vector search in just one streamlined powerful system. So I hope that's just a little bit clear, but I'm sure Gavin will talk a lot more about the ApertureDB architecture in the next presentation. I want to show a quick demo of the of my data, of my project here. There we go. Okay. So of course, simple thing is just you have to install all the libraries, then you import all the required ones. Here is how, in one line, you can create a configuration. This is something, once you create an account on ApertureDB, this is what your dashboard would look like once you upload some data. Now, I'll come back to this particular screen in a minute. Once I create a podcast chat, which is where I basically created my instance on ApertureData, and then I have my host, created my password, and then from the Colab notebook, I basically just use this one line of code to access that. And then you can check the status using just this particular line. You can see that, okay, system is running okay, all's fine. And then I connect to my instance using creating the connector client. And
Sonam, do you want to increase the font size just
yes,
that
thank you.
little bit?
Yeah, one moment, please. Hope this is good. Do not copy my password. But just kidding. So, Gavin, is this okay now?
That's perfect. Thank you.
Okay, great. All right. So once you're connected to your client on ApertureDB, you can check it will show you once it runs clearly with no error. It will just run simply. You can always check for any status if you wish. And now this is where I start the audio transcripts that I had. I have uploaded them, and this is what it looks like on your dashboard. Now, here you see this is a nice little representation of what my data distribution is like. It shows you what the descriptors, what the data type is. Um, and it will also show you like how many files you have, and if whether or not you're how much CPU you're utilizing, what's your storage consumption, and what's your memory consumption. So I don't have a lot of data here right now, but this is a nice little view on your dashboard that you can see. Going back to my code, um, here is where in this particular line, in this particular piece of code is where I call the cohere's embedding function. And again, Cohere embeddings, I'm using the LangChain integration for Cohere and ApertureDB. And you can provide your Cohere embedding model, whichever you're using. In this case, I'm using the version 3, and I believe there is a new version of embedding model as well that you can use. Once you provide what your embedding model is going to look like, you can call ApertureDB vector store, and you can enter, okay, this is the descriptor set, which is the embedding model in this case, and you provide the name for it. Once you have that set up, you will run that, and then you basically initiated that, okay, I'm calling the Cohere's embedding model. And here is where you can mention, or you can write what metadata from your actual database do you really want to access. So for this project, the metadata that I have is guest name, title, profession, their LinkedIn profile, the company they work on, and so on. So I basically, it's a simple simple line of code. In line number 20, this is where you basically connect to your Aperture vector store DB, and then you pass the query, which is what I have set up here. I'm not going to go into too many details of what each of these parameter means. We have the documentation is pretty self-explanatory. Now, once I have all these, once I have the metadata set up, you can see that I have over 600 documents, which is basically all the the text transcripts of my audio files along with their metadata. And here I'm just checking like, okay, what are the IDs? I think because of Google Colab, I think you don't see the entire output, which is fine. This is where I'm basically just adding these documents, which is the metadata of my transcripts, into ApertureDB. Now, here comes the fun part. This is where I start chatting with my data. I basically mentioned that, okay, I'm going to use a similarity metric. I want three results that are used by the LLM. And then after that, I would want like, the top results, top similar results. And I just basically call the retriever function, provide all my value, the parameter values in it. And then I go ahead and call the coheres command R model. Now, here comes the prompting. Now, once I have all the Cohere setup, Cohere embedding model setup, the retriever model setup, and vector store as well, I provide a template. I say that, okay, you are a question and answering chat assistant. You're going to use my podcast transcript data to answer the questions at the end. And of course, also share the metadata which come with it. And this is the basic, you can the LangChain basically provides a nice way of mentioning, okay, or training your prompt, your model, and the string output parser. Once I have all this set up, I start asking some questions. I've already run this, so now my question that I'm asking is like, how does RAG technique help in building LLM applications? Now let's see what the answer we get. Okay, pretty fast as you see. It will tell you that, okay, RAG is, it will define what the RAG is. Right now, it's not showing me the metadata. Again, no idea why. Live demos are hard. I will tell you that. And LLMs have their own thing. But anyway, if you scroll down, I have more questions that I have asked. Like, okay, what is a knowledge graph? It will basically tell you all the answers that it extracts from the podcast data. And in this particular answer, like you see, it explained, okay, what's a knowledge graph, what is the idea behind it. It will give you some examples as well. And now here you see that companies like Bytewax and BB8 are working on products. Now, how did this come into the picture? Because it basically connected the podcast episodes with the co-founders of Bytewax and VV8 who were guests on the podcast, and it basically retrieved the answer from those episodes. And one more example here I had asked is like, what are some of the AI industry highlights that you can share? It shared some answers such as, sector. It highlights according to the podcast transcripts. It will tell you that e-commerce, legal banks are implementing AI rapidly. Then it told us about, okay, Bob, who's the co-founder of VV8, has the database models, and then and Piyush, who's co-founder of Weave AI, he also mentioned or talked about generative AI for enterprises. And then I had this fun question asking, like, okay, what is the purpose of agents? Here is where you see, like, okay, the question I asked, and then it answered what the agents are. And then it showed, okay, this is the metadata that the answer was associated or retrieved from, where it says, this is the broadcast title. The guest company is Kentaurus AI, and guest is a founder. And it also showed, like, okay, which segment it came from. So the more the more you refine your prompt, you can of course get more detailed answer. But the great thing about storing your metadata, and again, this is something I can improve more on for this project, is that I can ask more detailed metadata related questions. You can access that because this is how it's stored on the database. And the next or the future improvement that I would like to do is extract the video segments where that answer was extracted from. So yeah, so this was just like a sample project that I wanted to do, and I can keep asking more and more questions, and the answers could be more refined based on the prompt that I give. So yeah, that was just a quick run through my project, and if there are any questions, I'm happy to take them.
Um, yes, there are questions. Can you hear me better?
Yeah.
Awesome. So, one of the questions we have um, is how is this different than DocRag? Is the data scalable?
Yes, the data is definitely scalable. And right now, I basically transcribed the audio files into text because at the time, the next step will be basically putting all the videos and storing video clips so you can chat with the video data as well because you can add as much more data as you can, as I said like in my slides, that it's definitely scalable and it the performance stays consistent basically. um, did I answer your question, or Gavin, if you would want to add more to that, please feel free.
You're on mute.
No, that's a great answer.
We have another question.
Shall I
And
take
that
that one? Oh,
um,
sorry.
and the question is, how is it different than running my own Mongo Atlas instance that scales? So I believe it was a question around ApertureDB and how is it a little bit different different than Mongo Atlas instance at scale that scales.
Right. So first of all, most of the features that you see that you find in ApertureDB, you do find in some other products. What's special is the way that we bring them all together into one highly performant, highly scalable, and cost-effective whole. So the way ApertureDB, what ApertureDB provides is multimedia. So where we have smart ways of dealing with text and images and videos, and you can also store audio or any file format you want. And we have various clever ways of doing operations on them. So, for example, if you search for videos, you can crop it down res it, extract frames, just to see like what you need. What you need to display for the user can be much lower bandwidth than what's actually stored on the server, for example. We have the labeled property graph, essentially, the graph database that's able to traverse the graph and find connections, filtering properties in the connections, all that sort of thing. And then finally, we have the high performance data store. So there are many of these features are available elsewhere, but it's the unified whole that gives a high performance, efficient, cost effective bundle.
And thank you, Gavin, for that answer. So I'll wait one more second if there are any other questions for Sonam before we move on to the fun part. Another fun look at the RAG workflow with Gavin. So before my audio troubles, one of the things I wanted to mention was that a recording of this lunch and learn will be made available to all participants who register. And you'll also have access to any of the notebooks or links that are provided throughout the presentation. And so now, one of the things that we heard from our customers was that we really wanted to make this process that Sonam went through easy and user-friendly to use. And today, you will be getting a first look, a sneak peek at ApertureDB's RAG workflow that Gavin will be presenting that shows you how bringing all of these elements together to build your to chat with your unstructured data using ApertureDB. So with that, I'll pass it on to Gavin.
Thank you. So I thought Sonam's half was the fun half, but I'll try to live up to that intro. um, I'm going to be talking about a new workflow that we're bringing out very shortly, which is the full pipeline from crawling a website through to having a RAG agent. But first of all, I'm going to talk a little bit about what are workflows. So this is one of our newer features, and it's essentially we're taking common tasks and we're bundling them up as reusable services. A key useful part of this is that they can be run in the same cluster in Kubernetes as the ApertureDB instance, and therefore the bandwidth costs are much cheaper than trying to run these remotely on your desktop or in your data center. Some of these are one-off tasks, and some of them run continuously. So there are three ways that you can use workflows. The easiest way is to go into the cloud portal and click a few buttons. I'll show you that in a second. The second is that most of our workflows are publicly published in a repo. I'll be pointing more at that in a moment. And you can use your own Docker or Kubernetes to run a workflow image against any ApertureDB instance you want. And thirdly, because the code is public, you can take it, used as an example, and adapt it for your own tasks. This is just screenshots of creating your own instance and your own creating a workflow through the cloud portal. I'll be giving a demo of that in a second. Here we are. The instructions are in the repo for running things from Docker. And in terms of customization, we have these workflows available. Use them as examples, adapt them for your needs. Tell us that we should be building new workflows because we're constantly adding new ones and developing the existing ones. So do let us know what you need. So what are workflows? What do they do? There's a whole range of different tasks that they perform. Data ingestion is a big one. You can pull things down from websites. You can go to cloud storage. There are certain prepackaged corpora that we provide. Embedding generation is a very common task. We don't do that on the server because we like customers to have the flexibility for whatever model they want, but we provide various mechanisms for you to have embeddings generated on the text and images that you've uploaded. ML inference is another big task, so object detection, identification, bounding boxes, even object tracking maybe. These are all tasks where you're pulling information out of the database, drawing some deductions, and adding new data types to record the information. And then the explore part, there's various services that you can run to get access to your data. You can run a Jupyter Notebook just for arbitrary prototyping and demonstration purposes. I'll be showing today how you can run a chatbot. There are other query services in the pipeline that you'll be seeing soon. So I'm going to switch to a quick demo. So I have here an instance that I've already created. This is our cloud UI. I'm going to go into my workflows. I'm going to select that I want a website chatbot. I'm going to run it on RAG Demo 4. I'm going to, hold on, I have some notes here. I am going to run this on our documentation website, just as an example. You can do it on your own website. I'm going to use Together as the LLM. You see here we provide 3. There's probably others going to be appearing soon. We ask users to provide their own API key, and I'm just going to give a secret token that secures the interface. I'm going to submit that. And if I go back to, if I go back to that instance, I'm just going wrong here. Something is, oops, the curse of the live demo. Never mind, let's keep going. Hopefully that will sort itself out in a minute. Back to this. So we have I've been describing this as one workflow. In fact, internally, it's implemented as 4 different workflows that are combined together. This makes it more modular. It means we'll be able to combine it in different ways in the future. First we crawl the website, then we extract and segment the text, then we generate embeddings, and then finally we set up the RAG pipeline. So the first 3 can be thought of as the full ingestion, inference, or ingestion phase for the RAG. And then finally we have the web service. So looking at the crawl, you saw me start it with a particular URL. There's also the possibility to, there's other controls you can make on the crawl, all sorts of things. We're using the open source Scrapy system. Scrappy, I don't know. So there's a lot of flexibility in how we crawl. Currently, it's configured that it does text, HTML, PDF, other possibilities in the future. And of course, we're recording all the metadata associated with the crawl that you would want from a crawler system. So that is more details of the crawl. All of this is available in the repo, and you can see the QR code there. The next step in the pipeline is the extraction workflow, which is where we're taking the documents and we're turning them into segments. So you take these various document formats, you extract the text from them, you end up with lots of segments. Some of them you merge, some of them you split, and you ensure there's overlap for context. This is the sort of input that RAG needs. It needs bite-sized chunks of the corpus, but you want them to overlap so that you don't split some crucial meaning across a boundary. And so essentially the task here is you're going to take the raw documents and turn them into clean, searchable text. Here is more details on the segmentation, which you can also see in the repo. So the embedding section, that's where we take the text segments that we extracted and turn them into vectors that can be used in vector search. So although we're just dealing with text here, we're choosing to use a multimodal model, specifically OpenClip, because we always want to leave the door open for doing things in a multimodal way, for combining text and images in the same search. I won't be demoing that today, but that's why we prefer multimodal models. So the vectors are stored in a data type we call descriptors, and the way this is stored is compatible with our line chain integrations. These are coming through as line chain documents, essentially, if that's the integration you prefer to be using. Here's more details of what's going on in the embeddings workflow. And then the fourth workflow is the RAG. This is the service that we stand up. So there's three things that this actually provides. It provides a simple API. You post or get the query that you want, and you get back the response. We also provide a streaming API based on SSE, because chatbots can be slow sometimes. Sorry, LLMs can be slow sometimes. So you want your chatbot to be dynamically responsive and show you results as they come through. And then finally, we have a demo UI that I'm going to show you. This is not the main product here, because if you were to use this yourself, you would probably take this as an example and put it on your website using the service API directly. But I always like to include an HTML demo when I set up these services, because it makes it easier to see what's going on. So we provide a choice of LLMs. You saw 3 of those on the list that I demoed a moment ago. The first one there, I include it because it's local, which means you don't need an API key, you don't need cloud resources to run it, but unless you assign the GPU configuration correctly, it's going to be underperformant compared to the others. The RAG pipeline also includes query rewriting, which I will demonstrate in a moment, and it keeps a conversational summary, which allows it a history, so it can disambiguate things as the conversation proceeds. Again, I'll be demoing that in a moment. Here are more details of the RAG process and the models. Again, this is available in the repo. So to summarize what's going on there, we've crawled the website, got raw documents, we've taken those and extracted clean, structured text from them. We've embedded those segments as vectors for vector search. And then finally, a fairly conventional RAG agent turns it all into a conversational interface. This is built from 4 modular workflows that can be recombined in different ways. When run through the cloud portal, it can be running close to your ApertureDB instance. and it's easy to customize, scale, or integrate this sort of pipeline. So that's the end of the presentation. I'm going to go back to the demo. Here we go. So why is this not liking me? Okay, plan B. Okay. Oh, I think it's just complaining about why is it complaining? It's not complaining about my login. Oops, let me try again. Never try to remember passwords in the middle of a live demo. Let me just see if this works. Well, we'll come back to that. I'm also going to show you the chatbots. Right, so here we are, basic HTML interface. I'm going to authenticate because we don't leave customer data accessible to the internet without some sort of security level on it. So here we are. And the first question I'm going to type is, how do I find a video? I'm deliberately misspelling that because I want to show you that it is automatically correcting for it. So here on the left, again, this stuff on the left is debugging information. This wouldn't be part of a real chatbot integration, but it's just here for demonstration purposes. We've rewritten the query as, what's the process for locating a video? That nice rephrasing of the question and fixing of my spelling error. And here's a nice answer that you get suggesting that we should use find video. And you see here the documents that it drew on to get that answer. I'm going to type a follow-up question, which is about cropping. So notice here that importantly, that's a very odd rewritten query, but importantly, it knows that that the cropping here is in the context of videos and not of images, because that's the context of the question. And then if I say, can I extract frames from them? Again, obviously it knows I'm talking about videos and gives me a good answer about, find frame connected to a video. And that's about it for demonstration of that interface. Let me just see if I can get the strange that this is not working for me. No, I should try to remember passwords in the middle of a demo. So that concludes the demo. And
thank you, Gavin, for the wonderful presentation around the new RAG workflows. So I'm going to pause and see if there are any questions for either Gavin or Sonam at this point. And actually, Gavin, in preparation for this webinar, I did get some offline questions. And and so I thought I would go ahead and this one actually particularly pertains to you. and that is, what kind of data gets stored in ApertureDB? Whole documents, segments, or just the descriptors?
So everything here is being stored in ApertureDB. From the whole process is modular workflows, storing information in ApertureDB, getting information back out of ApertureDB, processing it, and putting it back in. So the first stage here results in raw documents being stored full size in blobs in the database. The second, you take each of those, you turn it into a number of segments. We're actually extracting other things from there, like image captions and so on, that I didn't include in this demo. So there's really no, there's all sorts of things that can be generated, and it's all linked together in the graph and can be traversed and searched and so on. The third phase, you're generating the embeddings. That again goes into the database. So at every stage, we're storing things in the database, and all of those can be used for other applications later.
Okay, awesome. And for our participants online, feel free to type in any questions you may have with chat inside the chat. And I'll also ask another question that I also received, Gavin, as part of this webinar or Lunch and Learn, and that is, what happens if the site content changes or my data changes? How does that affect sort of this workflow?
Well, that's a good question. The current system that I just demoed is a one-shot. It runs very quickly, as you saw. It just runs in a matter of minutes. So this could realistically be run every night to refresh your website and update the data, stand up a new pipeline. It'll go through the phases, replacing the data, and within 5 minutes, you have a new crawl. In the future, we might introduce an incremental mode that notices which pages have changed, added, removed, and so on.
Sonam, someone wanted to understand, like, how long did it take you to create the demo that you showed us? So from start, how long was it?
Oh, okay. That's a good question. So from start to finish, I think it took me around 2 to 3 hours, mainly because I was figuring out all the transcription using Whisper and then learning the new terms. But I think it was around 2 3 hours in a stretch.
Okay, awesome. And then finally, on my side, can you so one of the questions around that I also received, Gavin, was, can you use different embedding models in the workflows that you just described?
Absolutely. So what I showed you in the demo here, we trimmed the options down to the minimum to keep it simple for the customers, but the underlying workflow, we provide a number of different embeddings. It's a pluggable interface, so it's very easy in the code to go in and add more. We do recommend, whenever possible, using multimodal embeddings, and so that keeps you with clip and open clip, and also we prefer to use open source when possible. So open clip is what we are using by default.
Awesome. Well, thank you for that wonderful answers. Well, it appears that I'll pause for one more second and see if anyone else has any questions on the chat. And
I have a question for Gavin.
Sure.
So this is coming with a very agent specific question because I work at an agent company. So how does ApertureData envision ApertureDB in the agent ecosystem?
Right. So although I've demoed here that we wrote an agent, we're not really in the agent writing business. This is a complete system that you can use to crawl your website and chat about it. But what we build are tools that support you in doing this. Here we've built a simple agent that uses an LM to do query rewriting, answer the query from context documents, and generate a summary of the conversation history for future queries. But there's all sorts of ways that ApertureDB can be integrated with LLMs and other agent technology to form new agents. So, for example, there's a lot of talk about MCP nowadays.
Oh yeah.
That's something that we are actively working on, and I hope I can be doing another presentation on MCP soon.
And like, could you talk about maybe agentic RAG, or like how does ApertureDB would handle if that's something, a use case that somebody wants to build?
Right. So if you look at say LangChain, a lot of what they want to do with agentic RAG is connect with LangGraph, where you're storing a graph representation of your agent's behavior and then executing that as you go. That's a very exciting possibility, and of course you can store graphs and interrogate them in ApertureDB. We're hoping to publicize better integration with LangChain's graph interfaces in the near future. It's unfortunately a little bit of a moving target as they are developing these very fast as well.
I see there's an agentic RAG example video that you guys shared. Cool. Thank you.
Thank you. And thanks, Sonam. All really interesting and, of course, quite relevant questions regarding sort of the role of ApertureDB in these emerging technologies. So if we do not have any other questions from the chat, I want to wish you a happy Wednesday. And thank you so much, both Sonam and Gavin, for the presentations on really how to use ApertureDB to chat with your unstructured data. And for the attendees of our webinar, thank you for spending some time with us to learn about the new technologies. Have a wonderful rest of the day.
Thank you for having me, guys. Have a good day.
Bye-bye.
Bye.
Thanks for coming. Bye.